Hello everyone. In this video we are going to find root of the function fx equals to cos x minus x using bisection method with the help of a scientific calculator. So here we are given a function fx equals to cos x minus x and the initial interval is 0 comma 1, and you can also check that f of 0 is 1, which is positive, and f of 1, this function, is negative. So the rule is that if fx is a continuous function on a closed interval ab, and if this function also satisfies the condition that f of a and f of b means the values of the function at the end points, the product of those two values is negative, then fx equals to 0 will have a root in the interval a comma b. So we will use this fact to find the approximated roots of this function fx equals to cos x minus x in this video. So here we have provided a table where I denotes the iteration, ai minus 1 is the initial value of the interval, and bi minus 1 is the upper limit of the interval. So if I is equals to 1, then ai minus 1 means a0, so a naught means initial lower limit of the interval, which is 0, and bi minus 1 means b0, which is 1 in this case. So what is the procedure? We have to calculate the midpoint of the function. So we will calculate the midpoint of the function, which is a plus b, not the function, we will calculate the midpoint of the interval. So the interval is 0 comma 1. So what is the midpoint of 0 comma 1? Is 0 plus 1 divided by 2, which is 0.5. So this is the value of m1, means first midpoint. And then we will check the value of the function at this midpoint, f of 0.5, which will come out to be positive, and we will check this by using calculator as well. So for the next iteration we have to select the interval again, because in the bisection method our aim is to bisect the interval again and again to minimize the length of the interval, making sure that the root lie in the interval by checking the condition f of a into f of b is less than 0. So if at the 0.5 midpoint value of the function is positive, and we have already checked that at 0 it is positive and at 1 value of the function is negative. So how to select the next interval? We will select the values of ai and bi, or ai a naught and b naught. So for the I equals to 2, this ai minus 1 means a1. So the next interval is basically a1 comma b1. So what will be the values of a1 and b1? So a1 is 0.5 and b1 is 1. Why? Because at 1 the value of in the previous interval at 1 the value of the function was negative, and now at 0.5 the value of the function is positive. So as the next interval we have to take 0.5 as a1 and 1 as b1 to make sure that value of the product of the values of the function at 0.5 and 1 is negative, to make sure that the root lie in the interval 0.5 comma 1 now. So we'll proceed this, we'll apply the same procedure for this interval as well to calculate m2 now. So m2 is this 0.75 and value of the function is negative. Then again we will repeat the process, because now value of the function is negative and in the previous interval it was positive as 0.5. So we will take the next interval as 0.5 and 0.75, because at 0.75 value of the function is negative now, and at 0.5 it was positive. So 0.5 and 0.75 is the next interval. So we have calculated the next midpoint here, and the value of the function at this next midpoint is now positive. So we will again choose the interval accordingly, because at 0.75 it is negative, at 0.625 it is positive. So the next interval is 0.625 and 0.75, and we have calculated the next midpoint here, and the value of the function is positive. So similarly we can calculate the some more iterations as well, but I have stopped at 4th iteration here. So how to solve it using scientific calculator? So I have written a statement here, m equals to a plus b by 2 colon cos m minus m. So we will type this equation in the calculator. So what it does, it will calculate the midpoint first, m equals to a plus b by 2, separated with column. It will also calculate cos m minus m, because the function is cos x minus x here, so we have to calculate the value of the function at midpoint fmi. So this is how we are going to calculate the value of the function at this midpoint, cos m minus m, because the function is cos x minus x. So at m it will be cos m minus m. So we'll type this equation and then we'll proceed how to do it, and we'll check. So we have to first type this equation, m equals to a plus b colon cos m minus m in the calculator. So you know how to type it, as we have discussed in the previous videos as well, how to write m equals to a plus b, alpha m plus alpha again equal to bracket alpha a plus b divided by 2 colon cos m minus m, right? Now press calculate key. So it is asking what is the value of a. So basically a is the lower limit of the initial interval. So lower limit of the initial interval is 0 here. You can check it. So press 0 equal to, so what is b? B is the initial value of the first upper limit of the first interval. So it is b naught, which is 1. Of course it is given to us, it is 1. Press equal to again. So this is the first midpoint 0.5, which we have written here, and if you press equal to again, you will get the value of cos m minus m, means fmi. So at the first iteration it is coming out to be positive 0.377582561. So we have written plus here. So for the next interval, what is the value of a now? It is 0.5. And what is the value of b now? It is 1. So at a, what was 0.5? 0.5 was the previous midpoint. So we do not need to write 0.5 here. We'll just write m in place of a now. Press equal to. It is asking what is b. B is not going to be changed in this case, in this iteration, because it is 1 itself. So b is 1 now. Press equal to. So this is 0.75 is the next midpoint. Value of the function is negative. And for the third iteration, a is not going to be changed because it is 0.5, as the value of the function is 0.5 is positive, and at 0.75 it is negative. So next interval is 0.5 and 0.75. So b is going to be changed now. It is 0.75. So it is m now. Basically it is m. Press equal to. So this is the next m value, 0.625. Value of the function is positive. Similarly for the next iteration, a is changed now, which is m. So I have written m here. B is not going to be changed, so B is as it is 0.75. Press equal to 0.6875, and value of the function is positive. So if you proceed in this manner, you can get as many as iterations as you want. Thank you.